block of a crystal lattice. Okay, it gives us the complete shape of the crystal lattice. Okay, over here we find that the unit cell is cubical, so we say that this is a space lattice which is cubical in nature, or this is a cubical crystal system, right? So unit cell is the smallest portion which repeats itself in space so as to give us the complete space lattice. So let us study about what are the parameters. Okay, you can see this slide later. Whatever is there, you can watch the video, pause the video and copy it down. Okay. Now, what are the unit cell parameters? There are 6 unit cell parameters. 3 of them are called the edge lengths. Okay, we know a cube is characterized by length, breadth and height, right? Length, let's see, length is A, let's say breadth is B and height is C. So ABC, okay? ABC gives me the edge lengths of the, or edge dimensions of the cube. And we have the edge angles alpha, beta and gamma. So depending upon these 6 parameters, we can define a unit cell, like what kind of unit cell it will be, whether it will be hexagonal, whether it will be cubical, whether it will be monoclinic or rhombohedral or orthorhombic, right? Now, this is the pictorial view of a unit cell. Okay, the pictorial view of unit cell, for your understanding, I'll explain you. So you have here lengths along z-axis, lengths along x-axis, lengths along y-axis. Okay, depicted by A, B, C in the figure, right? And you have edge angles. Okay, the angle between 2 of the edges B and C is depicted by alpha. The angle between 2 of the other edges B and A are depicted by gamma, and the angle between the edge lengths C and A are depicted by the angle beta. One interesting thing about here in the cubical unit cell is that the edge angles alpha, beta and gamma are equal to 90 degree, and all the edge lengths are equal. Okay, you have to keep in mind that one. Now we have 7 crystal systems. I'll zoom out this one. The 7 crystal systems are cubical, where the edge lengths are all equal and the edge angles are all equal to 90 degree. Alpha, beta and gamma equal to 90 degree. You have the tetragonal next, which has this particular shape, and here edge length A is equal to edge length B, but edge length C is not equal. Edge length A and B are not equal to edge length C. And here alpha, beta and gamma are all equal to 90 degree. Okay. Then you have the orthorhombic, then you have the monoclinic, then you have the hexagonal, then you have the rhombohedral or trigonal crystal system. Lastly, you have the triclinic. Okay. So in exam question comes like, if A equal to B equal to C and alpha equal to beta equal to 90, gamma equal to 90 degree, then what kind of crystal system it is? The answer will be, it is a case of cubical crystal system. Okay. And if I ask you which is the most symmetrical of all these 7 crystal systems, the answer will be cubical, okay, or cubic, right? Which is the most unsymmetrical one among all these 7? Your answer will be your triclinic, okay? Triclinic. Keep this in mind, all of you. So these are important questions that may come in the exam. Important points, as I've already told, cubical is the most symmetrical system and triclinic is the most unsymmetrical system. Now we'll discuss about the types of cubical unit cells or lattices. But before that, I'll just show you something. Okay, you have to go through this. It's very, very important. Okay. Yeah, let me first try this. The types of cubical unit cells are simple or primitive cubical unit cell, then body-centered cubical unit cell, and the last one is face-centered cubic unit cell. Okay, there are 3 types. So what is the simple or primitive cubic unit cell? In the simple or primitive cubic unit cell, we find that the atoms or particles are placed at the 8 corners of the cube. Okay, so there are 8 lattice sites where the atoms are placed. That is the case of simple or primitive cubical unit system. Now, unit cells, or simple or primitive cubic unit cell. In the next one, in case of body-centered cubic unit cell, we find that there are atoms placed at the 8 corners, and then one atom is placed at the center of the body of the unit cell. So that's why its name is called body-centered cubic unit cell. Lastly, in case of face-centered cubic unit cell, we find that the atoms are placed at the 8 corners of the cube, and we find atoms at the 6 faces, the center of the 6 faces. We know a cube has got 6 faces, okay? Just like in Ludo, you have played Ludo in your younger days, or maybe now still playing in lockdown days. So, center of all the 6 faces of a cube, there are atoms placed, plus there are atoms placed at the 8 corners. So that's how you classify simple or primitive cubic unit cell, then body-centered cubic unit cell, and then face-centered.